Hello, this is Professor Kitch, and this is Engineering Tools Using Excel Part 1, part of your Engineering 1201 Introduction to Engineering course. In this webcast, you're going to learn three simple tools within Excel. First, to create equations to compute a value, and second, how to copy that equation from one cell to another. You're also going to learn how to distinguish between absolute and relative cell references and how to use those when creating equations. The problem we're going to use for this exercise is that you are an engineer testing a new motorcycle design. In this testing, you have a track that's 5,000 meters long, and you've done a number of trials of your new test motorcycle around this track, and you've measured the time for each trial. You now collected all that data, and we need to analyze it. This Excel sheet contains the data from your motorcycle trial tests. In this column right here, we have the times for each of the trial tests, and the total distance covered is 5,000 meters as shown in this cell. What we want to do in each of these cells here, under the column that says velocity in meters per second, is compute the average velocity around the track in meters per second. And we need to enter an equation to do that. There's a very simple equation, and we know that the velocity is going to be the distance divided by the time. When we write equations in Excel, they always start with an equal sign, and that tells Excel that what we're entering is actually an equation and not just characters. So first we type equal, and then if we wanted to compute this number, we could write it simply as 5,000 divided by 132.13. And we hit enter, and we get the right answer, that the velocity is 37.84 meters per second squared. However, that's not a very useful equation, because if something changes, for instance, if the distance we measured it over was 4,500 meters instead of 5,000 meters, and I entered that in the distance cell, this number doesn't change. Or similarly, if the time actually wasn't 132.13 seconds, but 133.12 seconds, and I enter that in this cell, it doesn't change either. So we don't want to just type the equation in, as I've done here in this example, but we really want to use an equation that points to these cells, the time cell and the distance cell, so that we're actually computing the number on the fly. So let's do that again. I'm going to clear this cell, and I'm going to again start my equation by typing equals. But now instead of typing in the number for the distance of 5,000, I'm just going to point to that number. I'm going to click on that cell, and you notice that cell is highlighted, and you also know in my equation cell I see this D8. Well, D8 is a reference to the cell. It's not the value of the cell itself. Notice that this cell where the 5,000 is in column D in row 8. So what this says right now is, in this equation, put in the value that you find in cell D8. And then I'm going to divide by, and I want to divide by the time. I'm just going to click on the time. And notice that it highlights cell C12, and this cell is in column C, row 12. And now I've hit enter. I'll get the same answer, 37.84 meters per second. But now, if the distance happened to change to 4,500 meters, notice that the velocity changes. Or if the time changed to, say, 200 seconds, notice that the velocity changes again. So this is a much better way to put in the formula, because I've actually got a number that changes with the values that create the formula. And there's two ways to actually see the value of the formula in here. Notice if you look up here in the formula bar at the top, you don't see 25, but you see D8 divided by C12. That's the formula. Another way to look at the formula itself is to double click in the cell, and then you'll see it'll change from the value of the formula to the formula itself. And not only will you see D8 divided by C12, but it also highlights these two cells used in the formula. That makes it easier to check the formula. And if you just hit escape, it'll go back to the value of the formula. Well, now we have the value calculated here in cell D12, And I just need to do the same velocity of calculation for all these other values of the time that we recorded for the laps around the track. Now I could do that by going to each cell, hitting the equal sign, pointing to the distance, typing divide and pointing to the time, and then go to the next cell, hit equal, point to the distance, divide by the time. And I could do that and calculate all the way down. But that's really inconvenient. I want to show you how to copy this formula here in C12 down to all the other cells. Well, you might think you could do that copying just by clicking on the cell with the formula in it that you want, right-clicking and going to copy, and then going to the cell that you want to paste it in and right-clicking and clicking on paste. And you're almost right there, except see, something strange has happened here. We know that the value of the velocity here isn't 0, because it should be 5,000 divided by 122.97. Well, let's take a closer look at what's going on here. If I double click in this cell and you can see the formula, you'll notice that instead of taking 5,000 divided by 122.97, it's taking the cell below 5,000. Well, what's happening there? Well, this is the difference between relative and absolute cell references in Excel, and it's a really important thing to learn. If I click back on the original cell and I double click on the formula, we see here that the formula says to take cell D8 and divide it by cell C12. But that's not what it's really saying. It's using a relative cell reference, and the cell that the formula is in right now is cell D12. And when you say take cell D8, it's not really saying cell D8. It's saying take the cell that's 1, 2, 3, 4 cells above me, and then C12 says take the cell that's 1 cell to the left of me. That's the values I want you to put in this formula. And now if I come down to the cell where I copied that, you'll notice that it's copied the cell values but in a relative fashion to the place that they're located. In other words, cell C13 is 1, 2, 3, 4 cells above the cell where the equation is, just like it was in the first example. And cell D9 is 1 cell to the left. Well, when we're copying from this cell here, and I want to copy down the row, I want it to move the time cell down each row as the equation gets copied, but I don't want it to move the distance cell because I want that to be locked in up here. And by default, Excel always uses relative cell references when it copies. So what we really want to do is we want to take this cell D8 and we want to lock it in so it doesn't move when I copy the formula. And we do that by putting dollar signs in front of the two references, dollar sign in front of the 8 and dollar sign in front of the D. And that turns this relative cell reference into an absolute cell. So now when I copy it, it's not going to go 1, 2, 3, 4 rows above me. It's going to say, no, I just want cell D8 in there no matter what cell the equation is in. So if now I hit enter there and I come back to the cell and I do a control copy and then paste, now notice that the value there isn't 0 anymore. And if I peer into that cell, notice that the value D8 is still coming from this cell, but C13 has been moved down to the next cell. And I can do that for the whole row. I can come up here, I can copy this cell, I can highlight the whole row I want to put it in, and I can right click and paste, and all these equations will be right. So let's just pick an arbitrary one down here at D21. Let's double click on that one, and you'll notice that the distance value is locked in here at D8. That's what those dollar signs mean. But the time distance is being copied relative to the location of the cell, and it's the correct one. This is really pretty intuitive if you understand the difference between relative and absolute cell references. So now you should be able to create a simple equation in Excel to compute a value. You should also be able to copy that equation from one cell to another. And you should be able to distinguish between absolute and relative cell references and use the right one in the right situation. So now to practice that skill of creating a simple equation and copying it using the correct relative or absolute cell references, complete this column here in your spreadsheet for converting the velocity in meters per second in column D to the velocity in feet per second in column E. Now in your problem you're supposed to convert this to miles per hour. I'm doing feet per second just so you have to do something different. So the first thing I'm going to do is come up here and enter the conversion from meters per second to feet per second, and I happen to know that that is 0.3048. And then I just want to take the velocity in meters per second. If I multiply by 0.3048, I know it'll convert it to feet per second. So I'm going to say equals cell D E8 times, I use the star sign for that, and that's the correct conversion. Now I need to change this cell up here, E8, to a absolute reference instead of a relative reference. So I'm going to come up here in the equation and type E8, $E8. And then if I copy that all the way down here to this, all these cells will be right. And for instance, if I come to this cell and I double click on there, you'll notice that I have the right conversion and the right meters per second. So you do that now for your problem and have fun.